Hi everyone, and welcome back to the machine learning lecture. This time, our topic is another quite straightforward algorithm called k-nearest neighbors. This is the dataset that you've already seen in the last lecture. We have two features, x1 and x2, and class labels that we would like to predict. Last time, we approached this by using decision trees, which essentially divide up our feature space into rectangular areas where one of the classes dominates. In order to predict the class label of a new unseen point, we then just find out which region it belongs to and label it according to the dominating class. But there is another way to do this, and that is to just look at the points that surround our new data point. This is exactly what k-nearest neighbor is about. The simplest form of k-nearest neighbors is one nearest neighbor, where we look at the closest neighbor for all new data points. For this, we need to first define a distance measure, for example the Euclidean distance, compute the nearest neighbor for a new data point, and then label the new data point with the label of that nearest neighbor. This works for both classification and regression. So in classification, we just assign it the class that the nearest neighbor has, and in regression, we just give the new point the value that the nearest neighbor has. This is a result of applying one nearest neighbor to our dataset. You can see that we classify all of our training data points correctly. So even though we have a region right here that contains only green points, we still label the blue point here as blue, or the red point over here as red. And that looks a lot like overfitting. Therefore, in order to be a little more robust against outliers in our training set, we look at a number of neighbors. Let's first look at what this means for a classification. If nk of x is the set of the k nearest neighbors for a new unseen vector x, then in classification, we calculate the probability that we will classify that point as a certain class C as the fraction of points in that neighborhood with class C. In order to compute our target, we again take the arc maximum over all those probabilities. So this means that a new unseen point will be labeled by the mode of its neighbors' labels. For regression, we do something quite similar. Here, we use the k nearest neighbors to compute a weighted average of the labels of the neighbors. And we weigh each label by the distance of the neighbor to the new unseen point. And that means that the points within the neighborhood that are closest will have the most influence on the result. Together with the normalization constant, this means that we label a new vector x by the weighted mean of its neighbors' values. Looking at our example dataset again, we can see that if we chose k equals 3, there already seems to be less overfitting and better generalization. So the obvious question is, how do we choose k?